And you say,
Hi, this is John Kinzer, Mr. Kinzer, and we're starting our RGES Mid-High, Lesson 27, and we're in oceanography, so this is our science lesson. So if you will turn to your science section in your notebook, and these notes are to be taken right there where you would normally have notes in class. So this is just like class. So you're going to be writing every note that I have posted on this screen, and it's really kind of like a writing board. It's kind of cool. I like this. So we're going to have fun with this, and you'll probably see me make a few mistakes with it now and then, and I may even have to erase, but bear with me. Just keep writing and make sure you get all the notes as you do in class. Today's date is the 17th. This is because this is Tuesday, or if you're in the Thursday class, it'll be the 19th. So I'm just going to put the 17th or the 19th of March. So I'm going to put 17 or 19. So you pick the one that matches your class and circle it. Make sure you circle the notes for that you're taking in the notebook. So today we're going to be talking about the geological features of the ocean basin. And I'm going to go ahead and write that out here, the geological features of the ocean basin. And the ocean basin has a lot of topography. That means that the land and everything, it's not land, but the surface has a lot of features. So one of the things that we note about the bottom of the ocean, it is a very diverse terrain. Now, by diverse, it just means it's a lot of different kinds of terrain. And the terrain can be mountainous, it can be flat, it can have deep trenches. The first thing we're going to talk about is it has a continental shelf. And then we see continental. Looks like I misspelled that one. I'm just going to wipe out that T, okay? The continental shelf. And, of course, this bounds the ocean basins. Anywhere where there's a continent, there's a continental shelf that extends off the continent into the ocean. So the continental shelf is land that slopes away from the continent over into the ocean. So there's a slope as you go off the ocean or into the ocean from the continent. This is a shallow area. It normally walks out from the continent. It extends out about a half a mile in some places. In some places, like off California, it's a very narrow shelf. So I'm going to put a couple notes here. It's wide. You have a wide shelf in a place like North Carolina on the East Coast. And on the East Coast, we tend to have wider shelves. And so the beaches are also wider. You can walk out into the water. For instance, in North Carolina, you can walk about a half a mile out into the water, and it is just up to your chest. And that's kind of cool. You just walk out there, and it's almost like just a very gradual sloping, very shallow, a shallow ocean there. Now, how far does it go out to? Well, it goes out to about 600 feet deep. We'll make a note of that in just a second. So the shelf does go out to about 600 feet. Now, a second note is that you have a very narrow shelf in California. So California, on the Pacific side of the continent, you can't go out half a mile. You go out about 100 yards and it's over your head. So it's a narrower shelf. It's much steeper. And one of the features that exhibits that is that you have big waves in California. When you have a very narrow shelf and the ocean waves come in, the waves tend to curl over. And so people go surfing in California, and they like that side of the continent for that. But you'd never go surfing. I mean, you can do a little surfing in North Carolina on the east side, but the waves are very small. It's a very gradual, shallow continental slope and a shallow beach as well. So let's make a second note that from the continental shelf, where it starts on the beach, I'll put where the continental shelf starts, you've got a distance that varies according to where you are. It's a narrow distance on the east coast, a narrow distance on the west coast, California, very wide distance on the east coast, but it will start at that point where the water's edge is down to the ocean floor. I'm trying to get this thing to spell. Let's make an E there. There you go. Down to the ocean floor to a depth of 600 feet. So that's where the slope of the ocean floor begins at the edge of the land continents. Okay, so if we saw a little diagram with that, we'd have the ocean, and then we have the beach, and it slopes down. This is the continental shelf, and it reaches a depth of about 600 feet from the surface down to the edge of this continental shelf, and then it hits the slope. You see the slope begins. So we have the slope begins about 600 feet deep from the surface of the water down to the down to the edge of the shelf, where it kind of drops. Then it drops down into the ocean. That's the slope. So you go from a shelf to the slope. Okay. Now you also have on the edge of this slope, you have a feature called the continental rise. And so you have this rise, and then you have the ocean floor. So let's talk about that rise. That would be the continental rise. The rise is really just a very small rise before the ocean floor, before you reach the floor. So you're walking on the beach, you go down the shelf, you go to about 600 feet deep, the shelf falls off into a slope, and the slope moves to a rise. And there's this rise, this area here. I'm going to put a big R for that rise. And then, of course, the the ocean floor is below that. Well, this little gadget that we're using for YouTube is really fun. It's neat. And let's continue our trip now off the beach all the way down to the ocean floor. Now, when we hit the ocean floor, we go, of course, down the rise, and then we hit what's called the Abyssal Plain. This is a big, flat feature on the ocean floor. It's a flat floor, and it's covered with sediments. And the ocean floor extends out, and of course it goes out into the middle of the ocean. Now this is about an average of 1 mile deep worldwide. So let me go ahead and I'll write that down for you. So as we go down onto the abyssal plain, we reach that flat floor. So go ahead and copy these notes down. It's a flat floor. It's covered with sediments. These are sediments that have washed off the continent, carried down to the ocean by rivers, or they're just pieces of shells and pieces of fragments of the rock, the beach sediments that make their way out, carried out by currents, and they're deposited on the ocean floor, the abyssal plain. So obviously those sediments are deeper, closer to the continents. Way out in the middle of the ocean, it has a few sediments, but it's not as deep as near the continents. Now this ocean floor, as you can see on your notes, is about 1 mile deep. It's the average depth across the world. Okay, so this is a worldwide depth. It's a 5,300 foot average for the Earth. So this is quite a depth for the ocean. Now we also have seamounts, and you can see it's S-E-A, just like sea, mounts, M-O-U-N-T-S. Seamounts are these underwater mountains that do not reach the surface. So they'll be mountains that come off the ocean floor, and they're usually pretty jagged. They come to sharp peaks, and they do not break the surface of the water. Of course, if they break the surface, then they're an island. That's what we would call an island, like the Hawaiian Islands or Tahiti or the Philippines. Any of the islands that you see anywhere in the world, when it breaks the surface of the ocean, a big mountain that comes off the floor of the sea, it breaks that surface and it begins to then peak, and it forms an island. Now, a geo, G-U-Y-O-T-S, geo is a flat-topped seamount. Okay, so geos are out in the ocean, particularly in the Pacific. We see a lot of these flat-topped seamounts. They don't really know why these mountains are flat-topped. They think that it really is an occurrence perhaps when the ocean level was lower and the ocean eroded the top of a seamount and made it flat. And then the water level rose, and you have this geo that's underwater. So, in review, we've got seamounts, and we have geos. I'm going to take this off. That's not working very well. Let me write that again. We have seamounts, we have geos, and we have islands, which are, of course, mountains that poke through and rise above the water. So let's make sure that we make a note here. These are the rises above the water level or the water surface. There we go. Okay, now there are certain features called island arcs. An island arc is an arcuate shape. That means it's a curving series of islands. So a series of islands that have a curve to it. And these are all volcanic islands. So you see a lot of islands in the ocean are volcanic, but island arcs are always volcanic. So I'm going to underline volcanic. They're always volcanic. They form from volcanoes. We also have mid-ocean ridges. The mid-ocean ridges are exactly that. They're in the middle, in the mid-ocean. And these are ridges that kind of sharply rise off the floor. And here is where the ocean floor is spreading, because there's lava that's making its way to the surface, and it's spreading upwards from beneath the ocean floor. Let's see if we can go ahead and copy these notes about that mid-oceanic ridge or mid-ocean ridge. Again, it's in the mid-ocean, and it's where we have new ocean floor that's forming. And what happens is lava moves upwards from below the floor, and it moves, and when it reaches the surface, it spreads to each side. So here's the ocean surface, and when we have this ocean floor, and we see lava moving upwards because this is hot, there's a hot mass below the floor, and it moves upwards, and when it reaches the surface, of course, it spreads to each side. It'll spread to the right, it'll spread to the left, and you have what they call a spreading ridge here, or a mid-oceanic ridge. So because hot molten magma always moves upward, hot things always move upward. They move up like a hot air balloon always moves up. Well, hot lava will always move up. It reaches the surface and then spreads to the left and to the right. So you actually have new ocean floor at both X and X there. The new ocean floor as it spreads to the left or to the right. Okay, so we're going to review what all these features look like on the ocean floor and try to make a cross-section that you can label. So we're going to start over here on the left side, and over here is mountains and the ocean and the continent, and then we have this continental shelf. Of course, let's put the ocean in. Here's that ragged ocean, okay, going across with the waves, and it's coming up, and so this would be right here, the shoreline. This would be your shoreline. So I'm going to put an SL for shoreline. You can write the whole thing out. Shoreline, it's where the waves crash. There's a fancy name for this. It's called the littoral zone, which means the wave zone. That's what you'll get in high school when you take geology, but that's this zone right here. I'm going to kind of highlight it there a little bit. And it's where the waves crash, this little littoral. Here's where your shells are and some of the smashed up coral and things like that wash up here, and they get beat by these waves that are crashing on the upper portion of the continental shelf. So the continental shelf extends down, and of course at about 600 feet, it drops off. It becomes what? The slope, right. So we have the continental shelf, CS. We have the continental slope that is falling off to this rise area. I'm just going to mark it with an R. And then we've got the deep abyss, or the abyssal plain, which is that flat plain, the abyssal plain that we talked about earlier. Now, as we see this, some things stick up off the abyssal plain. We have seamounts, which will stick up, and they're kind of sharp topped. There's a seamount, SM, and we also have flat ones that stick up. There's a GO. Let's put a big G there. And of course, a volcano or a mountain that sticks up above the ocean surface would be an island. There's an island sticking up. Maybe that's the Hawaiians there. And some of you guys will get a chance to go visit the Hawaiians. That would be great. This could be volcanic. These islands would be volcanic, and some are coral reef. Some are what we call coral. So I'm going to put volcanic or coral. We can have coral reef, especially in the Pacific. And so all across the earth, we have this abyssal plain and then various features that rise from it. Occasionally we'll have a deep, deep trench. I'm going to kind of show a trench here. It goes way deep off, and of course this deep, deep trench has the weird animals, some of the weird things because of the great pressure of all that seawater that's pressing down at this depth. And we know that we talked about in class the Marianas Trench being the deepest. The Marianas Trench is the deepest trench in the world. We talked about that last week. We also have places where there's volcanoes that come up and they form an arc shape feature along the coast. That's called an island arc system. So let me do one last label. This is the continent. Make sure that you label the continent. And then we have our shoreline, this littoral zone, the Continental Shelf that extends off to a depth of 600 feet. And then we have the slope, the rise, and the Abyssal Plain with these different features. And you will be getting a worksheet that has all these features. You kind of fill in the blanks that you'll be working on this week. And I think it's a lot of fun, and some questions that you can identify. And then there's a little exercise that you will fill in, a homework assignment, using these notes, and then there's some thought questions. And fill that out and bring it back next week. It's called the Ocean Profile. So we'll be getting that to you this week. Thank you.
Well, no, actually. And then you just hit